In this video, I'm going to be rebuilding a vanilla JavaScript application to a React application. And the purpose of this video is to show you how you transition from that vanilla to React and what problems React is basically solving for you, why you would want to do this in the first place, and just some basic introduction to, building with React in general. The app that we're going to be rebuilding is this Tic Tac Toe game. And this is actually a game that I had created in a prior video, and I'd shown you how to go from complete scratch, nothing on paper, to a fully working vanilla HTML, CSS, and JavaScript Tic Tac Toe game. So the first thing we're going to do is learn how to set up a React app. So what that means, we're going to learn how to take a vanilla React app, so just regular JavaScript, and set it up from scratch. So from scratch. Let me zoom out a little bit. This step right here is going to take, I think it's going to be like over an hour. So if you want to skip that, if you don't care how it's set up, I would highly suggest that you learn this if you haven't dug into it on your own. But if you already know how this all works and you know what's going on under the hood to set up a React app, you can skip this. The next chapter is going to be convert from JS to TypeScript. So we're going to take that React app and implement it in TypeScript before we even write anything. And the reason being is I just want to do this project in TypeScript because it's, just the best way to write a React app, in my opinion, just so that you have strong type safety. And then finally, we're going to take the vanilla JavaScript app and convert it to a React TypeScript app. So I'm going to basically show you how you take the ideas that we put together in that prior video that you should have watched or at least gone over. We take that MVC model view controller pattern and we translate that to the paradigms that React actually works with. So you'll get to see how that translation looks and what problems React is trying to solve for us. So that'll be a really fun conversion that we'll be doing. And I will just highlight that this conversion is not me walking you through how to build step-by-step this app. It's really to just recognize those patterns. We're not going to be going through like, okay, now we're putting this element in and styling it, adding this event listener. We're going to be doing a lot of lifting and shifting, copy pasting and reorganization. So that's kind of what you should expect for this video. Let me be abundantly clear from the beginning. If you are looking for a video that is going to hold your hand to create a React app from scratch, this is not the video to watch. You should not be watching this video. I'll say this a couple times, but if you really want the best introduction to React, go to the new React docs and go to the Tic Tac Toe tutorial, no relation necessarily to the one that we're doing here, and go through this step by step and build this React app. This is going to be the best and most straightforward way to learn that. There are just a couple prerequisites to this video. Number one, and most importantly, make sure you're familiar with the code base for the Tic Tac Toe game. And the reason I say that is because I'm going to be glossing over a lot of the implementation details in the logic of like how the game works. So if you haven't seen the prior videos, which will be in the description as links, or at least read through the code base to the point where you understand the control flow and understand the goals of what we're doing with this game right here, so you can play the game, you can reset it, you can reset the scoreboard down here with a new round. It's a relatively simple game, but definitely need to understand what's going on. So that's the first prerequisite. Then HTML, CSS, and JavaScript, you need to be at least a basic proficiency in them. I have a 21-hour course in the description that you can go through if you need to get up to speed with that. So go check that out if you feel behind on those three. And then finally, a basic understanding of React and understanding what JSX is in the first place, the idea of a functional component, those basic concepts. And to do that, I would go to the React documentation and make sure that you're on the beta React docs not the old ones, because this documentation is way better. It was completely rewritten over the course of like 2 years, and they did an excellent job with this. So I would actually go to the Tic Tac Toe tutorial. This is kind of funny that this is the example that they give, and this is what we're building. I actually did not mean to do that. But anyways, go through this Tic Tac Toe tutorial and just skim through it. You don't need to, build it all from scratch. But the goal here is to just get a basic understanding, because I'm not going to be going through all the like really basic concepts like React props or component props and passing props down, that kind of stuff. We're just going to kind of jump into things. So that'll be great for you if you've already kind of gone through the basics. You just need to see a real life example built live, and that way, you can just follow along and try to pick things up as we go. And when I say a basic understanding of React, what does that actually mean? Well, I would expect that anyone watching this video can at least get some sort of React app working. They understand, what JSX is all about. So let's just write this down. Understand what JSX is. You should understand what a prop is. So this is just a property that you are passing to a component that component reads as part of their render cycle. So these are some pretty basic bare bones concepts of React. And then finally, you should understand what a functional component is. So just at a very basic level. And in the React documentation, make sure that you're on the new beta, or at least at the time of this video, it's in beta, but make sure you're on these docs, the new ones. They're great. They were rewritten over the course of 2 years, and lots of effort was put into this, and they're just awesome. So you can learn a lot from this, and I honestly, part of the reason I'm not making a beginner level React tutorial is because of these docs right here. I think that this is the best place to go learn how to build a React application. And specifically, before you start in this video, if you have no React experience, I would go to the quick start and at least skim through the tutorial on building a tic-tac-toe game. This is actually kind of ironic. I did not mean to replicate the same thing as the React docs. I actually didn't know that this was the example. So that'll be good. You can kind of read through their implementation and how they approached this problem, and then how I approached it in this video, because I was not looking at this when I originally built it. So skim through this, build it if you want to, can't hurt. And most importantly, go to Thinking in React and make sure that you've understood kind of the ideas here. And then finally, this will just help you along the tutorial that we're doing here. I would go down to Managing State, or actually, let's see. So adding interactivity, and go to the article or page that's called State, a component's memory, and just skim through this just so that you have a basic understanding of the use state hook, which is linked right here, because we will be using this throughout the video, and it'll be good to just have a basic understanding of it. Now I could sit here and say, go read this, go read that, but ultimately we're gonna just jump into some code, and the best way to learn is to just do things. So I will be sure to point out different parts of this documentation as we approach those specific concepts within the build. Obviously, you're welcome to read through any of this, and I would recommend reading the entire React docs at some point because it's just a good learning experience. But with that, don't want to waste any more time. If you meet these prerequisites, we will go ahead and get started. Okay, so we're going to look at React here, and specifically, where do we start? So as a beginner, or honestly even as an intermediate level developer, the question of where do you start when you're building a React application is actually more valid than you might think. Seems like a silly question, but there's a lot of ways that you can start building a React application. You could start as simple as just including a script tag in your HTML and using React like that. You could even include Babel, or Babel, however you say that, which takes the JSX and turns it into JavaScript. And you could use that all within the HTML document. So if we went over to our our refactor here, what I'm talking about is literally just putting scripts right here, and you could serve React from a CDN and you have React in your project. So that's one option. Another option is you could use like a code sandbox. So if we went to code sandbox, and here you can go new from template, and you've got these templates, React TypeScript or React. And if you click React, it will just spin up React application for you. It's working, and you can go ahead and add additional things to it. So hello again, and you're already programming in React. So this is probably the quickest way. Now you could also go to things like JS, which is kind of a meta framework sitting around React. You can go to create React app. I'm not even going to go through all of the possibilities. Just know that there's a lot of different options here. And the one that I'm going to choose is actually not recommended by really any documentation that you would see. If you go to the React Quick Start, it's going to give you an idea of where to start. So start a new React project. And if you go down to this section, it says if you're learning React, we recommend create React app. Now, the unfortunate thing about create React app and other alternatives that kind of just spin it up for you is that you don't get to understand what's happening behind the scenes. You don't really understand what React really is at its core. So the approach that I'm going to take here is actually a lot more similar to how Code Sandbox sets this up. So as you can see in Code Sandbox, if you go to index.js, you'll see this file right here where we're actually creating a root element in the DOM, and then we're using some React helper methods to basically render that React application in the root element that we've specified for React to use. This gets us a lot closer to what React is doing at its core, and so this is where I'm going to start. Now you might notice over here in the files pane, I know this is kind of small, let me make it bigger. You're not going to see any sort of build tools going on. So you're not going to see Webpack or anything like that. It just works. And unfortunately, this also makes an abstraction over React that makes you not really understand what's going on. So not only are we going to start right here at its most basic level, we're also going to kind of spin up our own build tools so that we understand how we're taking the JSX, converting it to JavaScript, bundling it into one file, and then including that in our index.html. Again, the purpose of this video is primarily to show you how you take a vanilla JavaScript application and port that over to React, and to show the problems that React is solving for you. And to do that, we need to basically do everything from scratch. So consider this a learning opportunity, not so much, hey, how do I most quickly get a React application working? Furthermore, the approach we're going to take in this video is not what I would recommend you use to create a production-ready app that you're going to, deploy and work on with a ton of people. This is kind of the most minimal setup that you could possibly have and is great for smaller projects. Some people would probably disagree, but I think Next.js is probably your best bet in terms of a production-ready React framework. This is basically a React meta framework that takes a lot of the common things that you might have to do in React, such as like managing images and routing and all that kind of stuff, different rendering methods, and it just comes out of the box ready to go. So this is what I would check out if you're wanting to build something in production. Anyways, not going to get too distracted there. Let's get started building our React app. So the first step with any project is to set up the initial, index.html and get it working in development mode so that you can basically just go over to the browser, and anytime the code changes, it will update the application. So that is the first step. And the way that we'll do that with React is, let's go ahead and create a new folder called Live React Refactor. And then our folder structure here is going to be the public folder, which is going to have like public static assets that we'll serve. And then we'll also have an SRC or source folder. This is where our React application and components are going to go. So in the public folder, this is actually where the index.html file is going to go, because this is a static file. There's really nothing dynamic about HTML, so we can just serve that directly. So let's go ahead and just copy that. We'll go back to the vanilla refactor. Once again, you should be familiar with this before watching this video. So we'll copy index.html and we will paste it over to the public directory. Now with React, we are building things with different paradigms. We are not including all of this HTML in this index file. We're going to be creating components to deal with this HTML. So therefore, we can actually strip a lot of this stuff out. So let's take pretty much all of the body content and delete it. The second thing that we're going to do is change the title. This is going to be the React refactor. And then just for the moment, we're going to comment out the script and save this. We'll put a little text in here, hello world. So this should be a basic HTML document. Now you'll see in the bottom right corner, I'm using Live Server. So I talked about this in prior videos. It's a VS Code extension that you can set up. It's running on port 5500. And that's actually what we're looking at here with the vanilla refactor. But if we go back to the base of this, you'll see that we now can look at the live React refactor and go to the public directory. And now we have a hello world document. Now, if we wanted to connect some styles to this, you can see we have this style sheet left over from the previous project, but it is referencing the CSS directory index.css. Now for this React refactor, I'm going to name this something a little differently. We're going to put a new file in here called globals.css. And the reason that I call it globals is because with React, we're able to kind of scope our CSS per component rather than per the whole project. And so this is just a naming convention that I'm using to make it explicit that anything that we put in globals CSS is going to apply to everything that we use and every component that we make. And that's because we're putting it in the index.html. To start us out, I'm going to go to the vanilla refactor and just copy everything from that index.css and paste it here. And we will eventually move some of this stuff out of this globals file into component specific CSS files. But for now, it's just going to all be there. And now we have to update our path. And this is going to be globals.css. And if we save this and go back to the browser, you can see that here's our hello world, pretty small there. But then we also have the correct background color. So we know that the CSS file is connected. Now, if we're just looking at this document, this is not a React application yet. There's nothing here that tells us that this is React. In order to actually convert this to a React application, we need the JavaScript to be controlled by React, and therefore we need a script tag. So what we're going to do is create something called an entry point. You might see this called index.js or entry point, or it could be named pretty much whatever. But in our source folder, I'm going to be very explicit and just call this entrypoint.js. And in this file, this is where we're going to initialize React. Now, going back to the code sandbox that I had shown you a little bit earlier, you can see this pattern right here where the code sandbox is basically importing React and importing the React DOM client and then doing something. You can actually find this in the React documentation if you go to add React to a website, and then I think at the bottom, run the JSX preprocessor. Let's see. So somewhere right here, you can see where it's calling create root and then root.render. It's not really called out explicitly, which is a little bit unfortunate, but it kind of shows you how you might know to do this. But anyways, we're going to write this out in our file. So the first thing that we'll do is we will import the strict mode for React. And the reason we'll do this is because it basically parses through your code and it finds all sorts of mistakes that you might make when writing a React application. It's just a good practice to get into to have that in strict mode. But you might say, well, how are we importing from React when we don't even have that included in our index.html or node modules? And the answer is we're really not. If we tried this, it's going to break. So at this point, we're going to install some dependencies for our project. So let's cd into the live React refactor. Then I'm going to run yarn init-y to accept all the defaults. This will save a package JSON to our folder here. Now what I'm going to do is add the required React dependencies. So really the only things that you need from React, yarn add React and then React DOM. So let's go ahead and add those. You'll see those populate in our dependencies. This is all we need to create a React application. So now we can go back to our entry point and this should work. Okay, now we need to import the create root method, and this will be from React DOM/client. And now here is where we basically insert React into our HTML document. Remember, React is just a bunch of JavaScript that knows how to basically manipulate the DOM and render things. It doesn't actually, create HTML files for you. You have to have an index.html to put it in. So what we'll do is we will define a root element, and this is going to be an element that we select from the DOM. So if you remember from our vanilla refactor, if we go to the JS and go to view.js, where we are selecting all of these elements via the query selector, and then we're in the query selector, we're basically just looking at the document and selecting an element. Well, we're going to do the same exact thing here. We're going to say document.get element by ID. This is the same as doing query selector with a hashtag in front to select an ID. It's just a little bit more specific if you have an ID assigned to an element. So we're going to get an element by ID, and we're going to call this the React root. Now, where did I get this name? Well, I made it up, and we're going to connect it here over in the body. So what you need to do is make a div, and then you're going to give it an ID and call it React root. So what this is doing is it's saying, hey, here's a container div. Now, React, find this container div and put all of your application code right here inside of it. So basically we're giving it a container to render into. And at this point we've just selected the root element. This is just going to be an element. Now we have to create the React root. So we'll call that root, and we will call the create root function that we imported from the React DOM client. And we're going to pass in that root element that we had selected. So that is the React root. And then finally, we can now call a React DOM specific method called render. And what we're going to render is a strict mode container. So now we're using JSX, and we're going to render strict mode, and then we're going to say hello world React. And this is just arbitrary JSX code. Now what you might notice is that this is a .js file. We could call this .jsx because we're using JSX in here, and then we'll get JavaScript React down here in the VS Code language mode. So it will just give us some better syntax highlighting. In addition to that, when we go to basically transpile these from JSX to JS, this file extension will allow us to kind of target this file to do that for. So let's save this entry point. Now let's go to index.html. We will, for now, keep this script out of here and save this. At this point, you might say, well, okay, all right, we're done with the initial setup for React. We've got this React root div, and then we've got this entry point.jsx, which is selecting it and rendering the React application within it. But if we were to go to the index.html in the browser, so our live refactor, and let's inspect this. If you inspect this, it's just going to show you the React root, but there's not going to be anything within it. And this makes sense if you really think about it, because what's happening when we request this right here from like some server. In this case, our local computer is the server that is serving that index.html file to the browser. But basically what's going to happen is the browser is going to load some path, and that path is going to make a GET request to some server. The server is going to send back an index.html document. Then what the browser is going to do is it's going to read through the document, and it's going to parse through all of the HTML, and it's going to also parse through any script tag that it sees. You can see that we've got a script tag here, but that's just injected by live server. That's not anything to do with the application that we've built. So what's missing? Well, as you can see in our HTML document, aside from this live server script, we don't have any script. So this code that we wrote in the entry point.jsx, this is just living in isolation right now. It's not actually imported and run within our index.html document yet, and so therefore it has no way to select that root and render anything. So your next option, your next guess might be, okay, let's just uncomment this script, and then we'll go to the source/entry point.jsx. All right. So we're trying to import that script, but if we go to the browser, that's obviously not going to work. If you go to the console, you're going to get loading module from blah, 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 because the MIME type was wrong. There's just going to be all sorts of problems here. And the reason is because a JSX file, one that has actual JSX in it, is not going to natively run inside the browser. You might get this stuff to run. We could probably see if that worked. So let's console log the root element. Looks like even that's not going to work, and I don't really care to debug that because we know that this is just not a good strategy in the first place. So pause the video and just ask yourself, if we can't do this, then what can we do? How do we actually get that JavaScript to run inside the browser in a script tag? And the answer is that we need to transform the code that we have written, the JSX code, into vanilla JavaScript, and then put that into another file, and then import that other file right here. If you watched the prior video, also linked in the description, where we took the vanilla JavaScript build and we refactored it to TypeScript, you might remember that we had some sort of build step where we had to take the TypeScript code that was not valid in the browser, and we had to compile that with the TypeScript compiler into valid JavaScript that we could run in the browser. This is no different. What we have to do here is we have to not necessarily compile. I think the correct term here is to transpile. So let's actually go look that up. So transpile versus compile. I should know this. So compiling is the process of taking source code written in one language and transforming it to another. Transpiling is the process of taking source code written in one language and transforming it into another language that has a similar level of abstraction. So in other words, it's not a real huge difference, and we don't need to get hung up on the differences there. But what I want to take you to now is a website, some documentation for Babel or Babel. I never know how to say this. And on the home page, if we just zoom in a little bit, what you'll see is that it gives you an example of how you put in some next generation JavaScript and then you get browser compatible JavaScript out. In other words, Babel, I'm just going to go with Babel, is a tool that will take some sort of JavaScript, some flavor of it that doesn't work in a browser, and make it work in a browser. One of those things that it can do is JSX. So if we come down to the presets, this is just the playground. You can see that it's using the React preset, so it knows, that we can write JSX code. And if we were to write, something like just a regular p tag, hello world, and then close that p tag off, what you'll see on the right is that it's using the React library to create a new element in the DOM and then render the hello world text within it. We could also wrap this in, say, a div. So we're just writing what looks like HTML, but really this is JSX. So now we're creating elements, and we could probably, I think in this playground, even write a component. So this will be a function component, and instead of just this isolated JSX, we will return that from the function. And oops, let's format this a little bit better. So you can see that worked, and it's returning a JavaScript function that returns these create element calls, and then we could even render that. So let's make our app, and then we want to return the component as a JSX component. And now you can see that all of this is going to be valid JavaScript. So this is just a .js file that we could include in that index.html file. So this right here is totally valid to put in this script tag. This right here is not valid, and it will not work. Now, Babel, under the hood, is running a bunch of code against this to get it to this state. And therefore, we're going to need some intermediate step to get it to this point. Now, once again, just like there's many ways to create a React application, there's also many ways to transpile code. And Babel is not your only option. Another option is you could use, if you're writing this in TypeScript, which hint hint, we are actually going to convert this to TypeScript in just a few minutes, you could use the TypeScript compiler to do this, because the TypeScript compiler actually supports JSX. You could use Babel, and you could also use something like Webpack, which is a build tool. So that's what we're going to do. I know this is not the latest and greatest tool chain. This is mainly for educational purposes. But if we go to some more documentation, let's go to Webpack docs. And now we're dealing with a bundler. So it does more than just bundle code, but the purpose of using Webpack is to take a bunch of different JavaScript files and squash them into one JavaScript file that we call a bundle. If you really want to understand why we need a bundler, I've written a post that I've referenced a couple times at this point throughout this video series, and it's the scripts versus CommonJS, UMD, AMD, ES6 modules. And if you come down to the bottom, let's see. So the last step, module bundlers. This is where I go through and explain why do we need a module bundler in the first place. So I'd recommend reading this short post just to get a better understanding there. But our goal is to basically take this entry point JSX file, and then we're going to have many other JSX files that will have all our different components. And instead of coming to index.html and copying this down and importing every single script that's been transpiled from JSX to JS, this is going to get very confusing. Our goal is to just do this. We're going to have one file, and it's going to come from the public directory, and it's going to be called bundle.js. And we don't need the type module anymore because we're using React code and we don't need to worry about that. But this is our end state. And I actually need to update this because remember, index.html is actually in the public directory. So we just need to reference it relatively. So the bundle.js will be output, keyword output, it's not created yet, into this public folder, and will sit next to globals.css and index.html. So the question becomes, how do we get it there? How do we get this bundle.js to compile into the public folder? The answer is Webpack or something similar. Once again, this has kind of gone a little bit out of style, but that doesn't matter. Our purposes here are educational to understand what's going on under the hood of React when we set it up in the first place. And you'll hear all sorts of things like, oh, Webpack's so outdated, but ultimately tons of projects are still highly dependent on this and will be for many years to come. So don't get spooked by anyone saying that this is irrelevant. This is very relevant, and the concepts that we'll learn through it are even more relevant. So let's get started. There's a lot to this documentation, lots of different configuration concepts, and I'm not going to go through these because you really don't need 90% of this for our purposes. So what I will do is just start writing the configuration, and we'll come back to the documentation to point out the individual options that we're using. So in order to start a Webpack project, we need to initialize it with a configuration file. Now, if you go to the documentation, there should be something about the configuration here. So introductory configuration, and you can see it's called webpack.config.js. So let's just copy this. Let's copy that default, and we will make in the base of our directory a webpack.config.js file. And let's just copy that basic example in there. Now, bear with me a little bit for the next couple minutes. This is going to get slightly confusing, and you're welcome to skip over this section if you want. I have time for this video, so if you want to skip over these details and just get started building the React application, you can do so. But I would highly recommend going through this section. It's really a good thing to understand what's going on here, and will serve you for the rest of your developer lifetime, just understanding this stuff. You probably won't have to touch it again, but it's good to just know what's going on under the hood. So let's take this line by line. First off, the mode. This is in development, and if you go to the concepts, let's go to environment, and right here it says the mode is an option that can be development, production, or none. And this is going to enable certain optimizations that are done in production. So Webpack will do certain things. I believe it's like minifying the code and stuff like that, depending on your environment. So we are in development. What we can do to make sure that this runs depending on our actual environment, let's say that we were deploying this somewhere. What we know is that the process.env.node.env is going to equal production when we deploy it on some server. This is just a default that any deployment site or cloud host is going to assign. So if there is a process node env, we're going to use that. Otherwise, we're going to use development. So in other words, development is our fallback, but we're going to look at the node env to determine what to use for this mode. Now this of course assumes that you're only allowed to assign development or production to node env. If you were, had like a staging environment, then this wouldn't work, but most of the time it's either production or development, so this should work. Now our entry, this is a little self-explanatory, so we don't need to go to the docs for this. This is going to be the file that Webpack will start from. It will start reading that file, and then it will trace all of the imports that have come into that file and kind of just walk down the code tree to find all the relevant files that it needs to basically bundle up. So in our case, entry point.jsx is going to be that. And we are in the root of our folder, so we need to look in the source folder, entry point.jsx. So we'll say relative to source, entry point.jsx. That's going to be our entry point. And then output is also somewhat self-explanatory. It's going to output a single file. We're going to call this just bundle.js, and it's going to put it into the dist directory. Now we're going to just rename this. Instead of dist, which stands for distribution, and it's a very common place to output your build output, we'll just call this public. And the reason being is we've got this public folder, and what we want is that bundle.js file to get output to public. Now, some would argue that you kind of want to separate these concerns, and maybe you want to output this to dist and then copy over your index.html and CSS to dist so that it's all kind of isolated into this, build output. But for our project, it's pretty simple. This makes sense, and we can just output this to the public directory. So let's save this. We will save entry point. And now the question becomes, well, how do we actually use Webpack? Well, you could install Webpack globally in your path, or better than that, you can install Webpack, pin it to a specific version for this project. That's what we're going to do. We're going to say yarn add, then we're going to add a -d because this is a development dependency. Remember, Webpack is just here to look at all of our code and bundle it up into something that can actually run in the browser. We don't need it after it has done its job. We can just run the code that it output and not deal with anything else. So what we can do is just add Webpack. So Go ahead and do that. And now what I'm going to do is go to package JSON, and we're going to add some scripts. Not necessary, but it's just convenience here. And something that I want to add is a build script. So this will run when we say yarn build, it's going to run this script right here. And what I want it to do is look in the development dependencies and just run Webpack. So we'll save that. And now what's going to happen if we run yarn build? So yarn build, it's going to invoke the Webpack binary that we just installed, and Webpack automatically knows to look for the webpack.config.js file in the root directory. And then this config has basically told the binary to look at this entry point, read through all the code, and output it to this bundle.js. But if we were to run this, we really haven't given it any instructions as to like how to do this. So let's just try to run yarn build, and it's saying that we need to install the Webpack client. I guess I had forgotten to do that, so we'll say yes. That's going to actually update our package JSON. You can see that here in dev dependencies, or I'm sorry, we're in the final one there, live React refactor. So now we have Webpack and Webpack client. So at this point we run yarn build, and you can see that we're going to get an error of some sort, and it says module parse failed, unexpected token. You may need an appropriate loader to handle this file type. Currently no loaders are configured to process this file. And what it's complaining about is this JSX that we have written. So if we go to entry point, by default Webpack does not know how to deal with JSX. It doesn't know how to transpile this right here. And this is where Babel will come in. So going back to Babel, we talked about how its job is to take this code and turn it into this code. And so therefore we need to add something called a loader to Webpack. So if we go to the documentation there, it says loaders are transformations that are applied to the source code of a module. They allow you to pre-process files as you import or load them. So I'm going to save us quite a bit of pain here, and I'm just going to show you how to get this working with React. I'll be completely honest, this is confusing stuff. I would not spend a whole lot of time beating your head against the wall to try to understand it at a super deep level. The overall goal here is to just understand the process that our code is going through, not necessarily all of these implementation details. So what we need to do is add a module property, and this module is a valid on the config, and then we'll say rules, and then we give it an array of rules. Now each of these rules is going to basically say like, hey, once you see this certain type of file in, coming from the entry point, here's how you actually, look at it and transpile it and bundle it. So the first rule that we're going to do is we're going to test. So this is going to be a regular expression that we're handing it. And we're going to say, if you see any file that has a JSX extension at the end of it, then go ahead and apply this rule. But if you see anything in node modules, exclude it, because we don't want to put that into our bundle. And then finally, here's where we're going to use a specific loader, and that loader is going to be called the Babel loader. Okay, so right here we're importing something that's external, so we need to install that as a dev dependency. If you go to Babel, got a lot of tabs open here at this point. Let's open one more. So Babel docs, and then let's just go down. If you go to presets, you can see there's a preset for React, and it gives you all this really confusing stuff. Okay, so here we get a list of all the different loaders that we can use. So let's start with the Babel loader. So we click on that, and it says, disclaimer, it's a third-party package maintained by community members. So this will need to be installed. And here's the install command. You need to install the Babel loader, Babel core, and preset. Now, I also happen to know that if we go to the preset React, we'll need this as well. So we're going to just kind of combine all of this into one command. So we will clear the terminal here, and then these are all going to be developer dependencies, remember, because we're just transpiling code. So we need to grab the Babel loader, so that's for Webpack. Then we're going to grab Babel specific packages, so we need the core module, we need the preset env. This is basically to just kind of normalize all the different ECMAScript versions and whatnot so that we can run JavaScript in all browsers. And then finally, Babel preset React. So we'll install all of those, and we go to our package.json. You'll see that they're all added right there. And now we can come back to our Webpack config, and this is going to work because we have that installed. And then we'll give it some options. Now this, I'm not going to go into a lot of depth because it's more on the advanced side, and we'll just assume that this is going to work. So what we first need to give it as a preset is the Babel preset env. And once again, this is just to make sure that, you know, all the different versions of ECMAScript, so ES3, 4, 5, 6, 2016, blah, 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 all of those, it kind of normalizes it so that the JS that is loaded is going to work in all browsers. And then we're going to give it an array where we give it the Babel preset React. And then this is really important. We need to give it a runtime of automatic. And the reason that we need that is because when we come to entry point over here, we are going to need that so that it automatically infers that React is part of this application, and we don't have to explicitly import React every time we want to use it. So that's the loader that we've set up. I know that this whole blob is a bit confusing, but just zooming out, the point of this is saying like, hey, anytime you see a JSX file that came, you know, as a result of looking in entry point, so in other words, anytime you see a JSX file in our project, go ahead and use the Babel loader and make sure you use the preset React, which is basically what we were looking at here in this sandbox, so that it takes this and creates this out of it. So now we might be able to build our app. So yarn build, remember that's going to run our Webpack script. And you can see that we got no errors. So that's a good thing. Now we're not 100% sure that this worked yet, but you can see in the public folder, we now have a bundle.js, and it's a bunch of ugly code that has been, you know, transpiled, and this is not something that you want to actually read through. Before we get any further, let's add a .git ignore to our project, because we've added some developer dependencies and build output, and all that stuff does not belong in source code. So first, let's look for node modules and ignore that. And then I'm going to do this, but this is probably not a best practice in any way. We're going to look in the public directory and ignore anything called bundle.js. And that's just because if you look at this, this is a lot of gibberish that does not belong in source control. This is an output of a build, and that includes pretty much the whole React library in it. So we do not want to put that in our GitHub repository, so we'll ignore that. Let's make sure that that is working, so we should not see any bundle.js. Sorry, there's actually some leftover code from my TypeScript refactor from the prior video, but the main point is there's no bundle.js. And if you look in Visual Studio Code, when it's ignored, it's actually grayed out a little bit compared to the other files and folders. So that's just a quick trick to know whether your file's been ignored correct. So the ultimate test is if we visit this index.html, which is importing the bundle.js that we just output using entry point as the source, does it work? So let's go to the browser. We can close this out, or I'll leave it open just so that we have reference to it. And now you can see right here, I gotta zoom in a bunch, Hello World React. So something worked here because if you look at entry point, you can see that that's where we're rendering the Hello World React. And so we know that our Webpack config worked and we are able to render JSX in our browser. And if we go ahead and inspect this, now you can see in the React root, that's where that P tag has been added. But there is one problem still, and that is if we go back to our code and we say by Zach or something like that, and then we save this entry point.jsx. Well, let's refresh the page and it's not actually working. And the reason being is because every time we want to add something, we need to rebuild the application. So we need to run yarn build again. That's going to compile everything and bundle it up, and now you'll see Hello World by Zach. Obviously, this is a poor experience as a developer. We do not want this to, we don't want to have to come and say yarn build every time we make a change. So this is where the Webpack dev server comes in, and that is basically going to look at your Webpack config, and on any change to any file that is included there, it's going to rerun this build step and output it to the bundle, which is then going to be served to index.html. And believe it or not, this didn't used to be this easy, but now you can basically just add one extra command here. So instead of build, we're going to give a dev command, which is our development only command, and we're going to say Webpack serve. And while we're here, I'm also going to add a build production script. And you know how we talked about over in the config, we've got this process node env. If we want to build it to production, we could just pass something like this. So set the environment variable and then call Webpack. So if we ran yarn build prod, it's going to just apply some optimizations to everything. And if we look at the bundle.js, you'll also see that there's a license omitted here. That would probably be good to include. So let's go ahead and just say bundle all, and that will include the license as well. But if you look at this, now it's optimized where like everything is minified. It's all, squashed together, which makes it a smaller bundle to load over the wire over an HTTP request. So yarn build is going to create something with lots of spaces and it's not optimized. And then yarn build prod is going to optimize that. But anyways, we want to run this in development mode. So let's run yarn dev, which is going to run the Webpack serve command. And this is going to say for using this command, we need the Webpack dev server package. So we'll accept that. You'll see that that was added down here at the bottom. And now you can see that it's a running process that is just waiting for changes. So we'll go back to our index.html. You can see Hello World by Zach. And then if we go to the entry point JSX, let's remove that and save it. You'll see that this just refreshed, reloaded. And if we refresh this page, it's not doing anything. So I am just not thinking whatsoever and totally messed this up. So if we try to go directly to index.html in the browser, and we are running this over live server, so localhost 5500, we're just going to get the static contents of the public directory. Now, if we look at the output of the Webpack dev server, it says that the project is running at localhost 8080. So we can kill the live server at this point. So we'll close that server. Now, if you reload this page, we got it way zoomed in. But if you reload this page, it's going to say unable to connect. But if we go to localhost 8080, now you'll see here's our Hello World React is working again. And then if we go back and make a change and save that, it's going to hot reload and update in the browser automatically. So the mistake I made, I was trying to look at the static contents from live server. We need to go to a different port here. The next step here is to replace this content with our app. So we can come over to our files and next to entry point, let's call it app.jsx. And this is just going to return a basic application wrapper that we're just going to consolidate all of that logic to. We can go ahead and use ES6 modules. So we'll export a default function called app, and then this will return some div and then say my app. Now we can import that into the entry point. So import app from app, and then replace this content with the JSX element, just like that. And we're getting an error. I think we might need to say app.jsx. Yep, that's all we needed to do. It couldn't resolve that without the extension. And I believe that happens because our Webpack config doesn't know how to kind of parse through and import that if we don't have the extension on it. So now this entry point is basically done. We don't have to look at this anymore because it's all set up. And now we're going to be working from this app.jsx. So let's go make sure that it works, my app. Now let's connect some per component styles. So we're going to use just vanilla CSS. And one way that we can do that is by using CSS modules. So we can say app.css, and let's go ahead and select everything in this app and make it the color red. So this is not going to work by default if we just look at our app, but all we have to do is import, and then we just import the app.css. Now you'll see that there's some errors down here and we're not able to compile, and that is because we have not specified a CSS loader. Right now we have an entry point of this, which is going to eventually make it to app.jsx. Then it's going to import app.css, but we don't have any rule for that. Right now we're only looking for JSX files. So if we go back to the documentation for Webpack right here, and we go back to loaders, you'll see that there's some different categories, and one of them is styling. So we have the style loader, add exports of a module as style to the DOM, or CSS loader, load CSS file with resolved imports and return CSS code. We're going to need both of these, and these are third-party packages, so we'll have to install them. So let's come down to our terminal, open up another one. Actually, let's just cut the server for now, and we'll add this as a developer dependency. We'll call it, we got to get the style loader and the CSS loader. Once we've done that, we can add another rule. So remember, rules is going to be an array, and we can specify a CSS rule. So here we're going to test and look for any .css files. So that's what we're looking for, and if we find them, we're going to use the style loader and the CSS loader. So let's save that. That's our final rule that we'll add, and let's run yarn dev. And now you'll see everything compiles successfully. And if we go back to the React refactor and refresh, we had to refresh that first time because we had restarted the server. So it's red, and now if we change this to green, it's going to hot reload and everything's going to be green. So at this point, we have our entire Webpack configuration done. We have our entry point to the React app set up, and our index.html is importing that bundle that we are, basically compiling and bundling together with the help of Webpack and Babel. I know we've spent a solid amount of time just setting up this React app in the first place, but I hope that it has been educational and given you a better sense of what's going on under the hood. This is basically what the Create React app and all of the other, frameworks that let you set up a React app, they're all doing some version of this under the hood, but that's abstracted away from you. And so oftentimes you don't understand what React actually is at its core level. So there's one more thing that we're going to do, and I kind of debated this a little bit, But I want to build this React app with TypeScript rather than, doing a whole another additional video where we refactor it to TypeScript. I think using TypeScript is really awesome, especially with React apps and across the stack. And it's not going to be too difficult to translate what we have here to TypeScript. And it will also give you a better idea of how we translate vanilla to TypeScript from a build step perspective. If you're not interested in this and you just can't wait to get started, once again, timestamps are in this video. Skip to the build where we actually start building out this application and, translating it from that vanilla JavaScript to React. So let's cut this server. And I will also add that there is a TypeScript branch and then a main branch for the repository in the description that follows and basically has all the final code here. This is a combined video, so you can find the vanilla JavaScript React app in the main branch, and then the one that we're building in this video will end up in the TypeScript branch. So I'll leave that in the description and kind of label it so that it's clear. So if you haven't watched the prior video where I converted a vanilla JavaScript app to a basically vanilla TypeScript app, go watch that because it will cover a lot of the basic concepts that I'm going to gloss over in the next few minutes. So I'll leave that in the description, but the first thing we need to do is install TypeScript. So we'll add that as a developer dependency. Once we have that, then we can run yarn tsc, which is the compiler, and we can run init. This will create a tsconfig, although I missed something here. It's not init, it is --init. So that creates a tsconfig.json file. Now there's all these different options here. I'm going to go ahead and just copy the final one just because it's going to save us some time. Okay, so this is the basics. The things that I'll point out here, this is pretty much the same as that prior video that we did. But just to point out, we're targeting ES6. So that's the version of JavaScript that the build output will be. And there's one thing that I've left out on purpose here, and that is a property called JSX. So let's go to the TypeScript documentation. So TypeScript, and then docs, and then go to the reference for the configuration file. So I'm not really sure where this would be. TypeScript tooling, reference, let's just search it, config, writing a configuration file. Gosh, this is very indirect. I want to just go to the reference for this. Let's go TypeScript config reference. Not sure why that's not searchable easier, but maybe I'm doing something wrong. So anyways, let's find that JSX property that we had just talked about. So that's down in language and environment. So JSX, and it says controls how JSX constructs are emitted in JavaScript files. This only affects output of JS files that started in .tsx files. So we have a couple of options here. We have React, React JSX, JSX dev, preserve, and native. This preserve option would be good if we were wanting to basically compile our TypeScript to JavaScript, but leave the JSX as it was, and then use Babel to take JSX and convert it to JS. Now, for this simple of a project, we don't really need all that indirection. We can just use React JSX and get all of that to happen for us. So let's give it to the JSX property, and we'll pass in React JSX. And so now the TypeScript compiler is not only going to look at our TypeScript and convert it to JavaScript, it's also going to recognize JSX and convert that to JavaScript. So it's kind of an all-in-one solution, which means that we can remove all of the Babel stuff that we had just added. That was good to understand, how you would do something with a vanilla application, but if you're using TypeScript, we can remove a lot of this complexity. So instead of using all of this Babel stuff, we're going to use the TS loader. And if we And we're also going to need to change this to TSX, so it only searches for TSX files. Finally, we'll need to update all our file extensions to TSX so that it knows to grab those. We'll come back to these errors in a second. Those are type errors that we're getting. Let's just save this for now. So now we have all TSX files. And let's go back to this TS loader. If we find this in the loaders, it's right here for transpiling. It says it loads TypeScript 2.0 like JavaScript. So this is also going to be an external one, I believe. So we'll need to install it. So let's open up our terminal here and look at our package.json. Right now we've got all these dev dependencies. We have Babel core, preset env, all of these Babel stuff. And we don't really need it anymore because TypeScript has taken over, the TypeScript compiler has taken over and done all of that job in addition to compiling TypeScript for us. So we can yarn remove all of that stuff. I'm just gonna take a little shortcut and just delete all that. We still need the CSS and style loader, and then we of course need Webpack because we're still using that. So let me save that and just yarn install. So that's gonna refresh everything. And then let's go ahead and add a developer dependency called TS loader. So now we have the CSS, style, and TS loaders in our project, and that should work for the Webpack config. Now, if we try to build this, we're going to get some errors. Oh, okay. Duh. I need to update this to TSX because we're not able to read the entry point. All right, so now we're getting some errors, but it's a much better error. It's looking for type files for everything, for React and all that stuff. And so now we just need to install those. You'll see an entry point. It's going to say try npm save dev types React. So that's all we're going to do is save the React types, and then I believe we also need the React DOM types. And you can see this goes away. Root element, it's just complaining that it could possibly be null. So one thing we could do is we could say if there's no root element, then throw new error React app configured incorrectly. And now that's going to solve that because we know that that will exist. I tend to just put a exclamation at the end to say like, hey, we know that this root element is going to be found. That's okay to do in this case, I think. But yeah, if you wanted to be safe, you'd throw an error or log something or whatever to make sure that that root element was selected correctly. Let's try one more time. Yarn build. And now it successfully built things into the public bundle.js. So that compiled TypeScript to JS and JSX to JS. So everything can now run in the browser. And let's make sure that that worked by going not to localhost 8080, but to the static app that we had. So localhost 5500, we cannot connect to that because live server is not running. But if we hit go live on live server and then refresh and go to live React refactor and then the public directory, you can see that we have an app running with some styled green text. So that means that our final build worked okay. And then if we were to go to yarn dev and run that dev server at localhost 8080, and refresh, you'll see that it refreshes, and once again we can go change this to red again, and that should hot reload and change the CSS of this app. Let me close a bunch of stuff out. We'll close all the save files, collapse all this, and I'm going to collapse this terminal. It's just going to be running in the background. And if we run into some errors, we'll pull it up again. So if you remember from the prior video that we did, where we refactored everything, the live TS refactor, we basically took the Tic Tac Toe game and we turned it to a TypeScript code base. So we've got the app, we've got the store, and we've got the view, and then we have our types file. This is what we're going to be referencing, and we're going to be just lifting it over and putting it into React code. While we're doing this, I'm going to run a live server, and that's going to be over here on this tab. We'll just grab localhost 5500, and I'm just going to run the vanilla refactor just so that we have a working final version of the game. So this is just vanilla.js, nothing fancy. This was from the first video. This is just our reference point, and we will eventually reach that same point over here in the React refactor. The first thing I want to do is bring over our types file. So let's copy this file of our types and put that in source. And looking at the types, we just have a player, a move, game status, game, and game state. The next thing that I want to do is copy over the HTML. So we had index.html that had all of this structure for us, and we had the main tag as well as the footer, and then finally a modal that opens when the game ends. I'm going to go ahead and copy all of this, and just to start us out, we're in the live React refactor again, and we'll go to app.tsx, and instead of my app, we're going to return all of this HTML. So all that HTML is going in there. It's going to yell at you because we need to put a fragment around this because we have no parent element to all of these. And then of course, we need to update all of our class attributes to be React compatible or JSX compatible attributes, which will be class name. So let's add that as a class name. So that should fix a few things. Then all of our comments, we'll just get rid of them for right now because those are not valid JSX. And then finally, you'll see that the style needs to be converted. This one will be a little bit annoying to do. So let me just kind of speed through this real quick. So I'm just copy pasting everything from the final version. Okay, so we've converted the HTML to valid JSX. No errors going on here. So we should, remember we have this server. I guess I'll keep it open here just so we can see a little bit of it. So that should be reloading every time we save. And now you can see in our React refactor, we've got something working. We have red text everywhere because I have not removed from our globals, or no, not globals, it was app.css where we added this. Let's get rid of that because that's annoying. And you can see now we have all of the structure and style to our application. But if we try to click anything, it's not going to do much because we don't have any event listeners or anything hooked up. Let me go ahead and just close all of these tabs. We don't really need them anymore. So the first thing that you'll want to do when you convert something over to a React application, or you're just building a React app from scratch, is look through your structure of your HTML and find what parts of this will be best as an individual component. So the first one that's pretty obvious that I'd like to kind of rebuild is the footer. This could be its own component. And so what I'll do is I'll just start using this convention. Let's add a new folder called components. And then in components, I will just add a footer.tsx. And then the styles for that footer will be footer.css. One could argue that, this organization is not the best, but it'll work for now. So the template that we're going to work with here is basically we're going to export a default function from each of these component files. And I'm trying to do this in the CSS file. Oops. Okay, so that looks a little bit better. So we're going to export a default function and then return some JSX from that. And then we're going to import the footer.css at the top so it gets all of the component specific styles. And then here we can just go back to our app.tsx and let's just copy the footer entirely and paste it right in here. So this will self-contain the footer, and I don't think there's anything that we need to modify here. So we can just leave that as is. And I don't actually think that yes, we do have some styles for that. So in our globals.css, where we have all of our styles right now that applies to everything, we want to come down and find the footer styles. So right here, this is where all the footer styles are. Let's rip those out and add those to footer.css, and then save both of those. And so now the styles and the HTML should be scoped to this one component, and we can finally come back to app.tsx and remove the footer and replace it with our footer component. And if you hit Command period, it will add that import for us, as you can see right here. So it's added the footer, and our Webpack is going to hot reload, and you'll see the footer right here down at the bottom. It's working. And if you go to your developer tools, let's actually look at Firefox extensions, and let's look for React and grab the React developer tools. All right, so now we have some React developer tools, and I think if we refresh this, yep, we can now see the components. So you can see that the footer is one of our components now. So this is, let's zoom in a little bit. I guess I can't zoom in. Unfortunately, I don't think I can zoom on the developer tools too much. It's pretty small. Okay, the next thing that we can do is break out the modal itself. So this right here is the modal that we will pop open when someone wins the game. We can bring this over to the components and call it modal.tsx with modal.css as the styles. And I'm just going to use this template again. So export default function, remember to import our CSS. And now what we'll do is we'll grab all of this right here and return it from this component. We'll go to globals.css and find all the modal styles which we've organized. This is another reason to organize your CSS so that when you refactor, it's pretty easy to know what goes where. So we put the modal CSS here. We'll save global styles. We'll save that component, and then we will once again add the modal. Oops, we need to import that from our components, and you're going to notice that this is going to mess things up a little bit. So if we come to our refactor, well, actually it doesn't mess anything up because we still have that hidden class. So if you'll see the modal hidden class, we're going to now control these sorts of things with React rather than classes. So I'm going to get rid of that. I'm also going to start removing all these data IDs because we're no longer having to select the elements. We can just grab them directly from React. So now once we remove those classes, you'll see down here at the bottom, you get this weird modal happening. And let me see what's going on there. So if we look at these styles, I think what's happening is we are setting the position to be fixed, but we're not giving it a reference point of where it should start. So let's give it left 0 and top 0, and now that should work okay. Once again, you can't click anything. There's no JavaScript functionality quite yet, but that should be styled correctly. And then if we come to app.tsx, now instead of using a hidden class that will toggle with some implicit event listener, we can just be more declarative about this and keep a state of whether the modal is open or not, and then render it conditionally here. So I'm going to just create a variable right now. You'll see how this comes into play a little bit later, but we'll just make a static variable called show modal, and we'll set that to false to start. Once again, you'll see how this changes in the future, so don't get caught up on how I'm not using state correctly and stuff like that. So show modal, we're just going to wrap it in this just like that. So now we will be able to conditionally show the modal. And then furthermore, what we might want to do is add some props to modal so we can pass what we want to show. Remember, we are going to control this text right here with JavaScript. So it would be good to add a message as props, and then we can define a props type up here that has a message of type string. So right here, we're destructuring from the props object and we're typing it right here. And now instead of player 1 wins, we can say that is set to the message that we pass to the modal as props. Now, since this is a required message, if we go back, it's going to complain because we haven't given it all of the props. For now, we're just going to say player 1 wins because we don't have anything dynamic to pass quite yet. But now you can see if we were to toggle this from false to true, it's going to show the modal and pass in player 1 wins. And just to check, we can look at our components again, and now we have a footer and a modal in our app. So let's put this back to false for now. So that's not going to show. And move on to the next part that we're going to refactor into components. All right, so looking through the rest of this, we could of course make a scoreboard component, but this is not a whole lot of HTML. I think we'll just leave this here. That's really a style preference, whether you'd split that out. This right here, we can simplify using some React conventions. So this will be rather simple to do. So we'll just open up some brackets here, and I'm going to make an array that goes 1 through 9. And you could of course create this with some JavaScript, but let's just be expressive about what we're doing. It's a lot easier to follow. And then from here, we're just going to map, and we're going to call this the square ID, is what each of those numbers will represent. And then for each of the square IDs, we're going to one of these div elements. Now, whenever you map across multiple elements in an array, React needs to know the key that you're giving it. And the reason is so that it has a predictable order that it can put these elements in. And when it goes to re-render and figure out whether each element has changed and it needs to re-render in the DOM, it will look at that key to tell it that. So we don't need this ID anymore. We also don't need this data ID because we're not using that old vanilla syntax. We do need the key here as I just described, and we can pass it the square ID, which is basically going to be the number on that square. And then furthermore, in our vanilla application, we were using JavaScript to render an I element, or basically an icon, in this div. So if we look back, when we click something, or sorry, this is the React app we have. If we click something in the finished app, it will put one of those icons within the box. So what we can do in React is, instead of implicitly doing this, we can be, or imperatively doing this, we can be more declarative and just say, let's just put an I tag in there, give it a class name, and we know this is going to be FA solid. Now we're going to have conditional classes based on which player is currently up. We haven't implemented that quite yet, but for now I'm just going to pass in FAX, and then we'll say, I think that was yellow was X, or no, I think it was turquoise is what we had for player 1. We will of course come back to this, but if we render this now, and then at this point we can get rid of all of these, so just reducing that amount of code. Now you'll see there's an X rendered into each of those. So we'll leave that there for now. We'll come back and make that dynamic later. Scrolling through, we've got the menu. This could actually be a good use case for another component. So we'll make it a menu component, and we'll export the default menu function. Oops. And then this menu is going to have some props. So we'll initialize that. And then we also want to import the menu.css, which we need to add over here. So there's your menu CSS. Let me close a bunch of these to clean us up, and we'll just open, oops, this is from the final. So there's our menu and our menu CSS. Now the first thing we'll do is let's go over to globals and look for those menu styles. So it looks like we got them right here. So let's copy all of those. I think that's all that we need. We'll throw those in menu CSS, save globals, and then we'll go to index.html, or I'm sorry, not index, app.tsx. And at this point we can grab all that HTML. Whoops, did that wrong. So we'll cut that out of there. And then in our component, we'll just render that div right there. Let's clean all of these data IDs up, because once again, we don't need that since we're working in React now. But pretty much anywhere that we have one of these data IDs means that we're registering it for a click listener. So we'll have to set up those click listeners here. So what I'm going to do for this menu is give it an onAction property, which is going to have an action type, which will either be a reset or it's going to be a new round. You could, of course, do this differently, however you want. I'm just simplifying things so that all we have to do is check the action type and then we know which of these buttons was clicked. So we'll come down to the buttons themselves and we'll say onClick. And this one will be an onAction. Oops, we haven't passed the props yet. So let's initialize these. So there's your onAction and then there's your props. So that's grabbing from here and typing it out. So now we can say onAction, and this will be a reset. So you can see we get this TypeScript support because we have this union type. So there's your reset. And then here's another click listener. We'll say this one is going to be the new round. So once again, you could split this into two. It's just stylistic. You could comment this out and say on reset void and then on new round void, and then replace these with those two different ones, and then come down here and instead of passing the key, we'll just say on reset and on new round, and that would be the same. So same thing, just a stylistic concern. So I'm going to go back to my original. I like that a little bit. So now we can throw the menu here where we took that JSX out. So there's your menu, and then we of course need the onAction. We'll fill that out in a second. So let's import the menu, command period to get VS Code to do that for you. You can see it got imported right there. And then the onAction for right now, we're going to just put a placeholder in there, and it's going to pass us an action because that's what we defined. And we're just going to console log it for right now. We'll eventually hook that up to something. Now, if we go to our app, when you click the actions menu, you're going to see in the console, it should, or let's refresh. Oh, we're not getting anything because we set those listeners on the menu items. But we also need to listen for a click to the topmost menu. So what we're going to do is put a click listener on the actions button, and we'll handle this internal to the menu. So we'll say whether this is menu open will be a piece of state that we're going to introduce using the useState hook. And then what we'll do is we will look at the, let's see, we've got a function and we're going to set menu open. And basically we're going to implement toggle functionality by looking at the previous state and returning the opposite of that. So it's complaining about this because we haven't initialized this to anything. So by giving it a false default state, that's going to type our use state and this as a Boolean because it's going to use type inference, and it's going to initialize this to be closed. But when we click that actions button, it's going to basically toggle the menu open and closed. We can verify this by going to the UI and clicking this, and it's not going to do anything because we're not actually reading this menu open state. We want to conditionally render this piece of JSX based on whether the menu is open. Now we have this leftover hidden class, which we need to get rid of because that will override this behavior. So now let's open this up, click actions, and you can see we can toggle this back and forth. The last thing is we need to look at this icon, and remember in the vanilla app we had this flipping depending on the open state. So we can come down here where we're rendering that icon and basically say, hey, if the menu is open, we're going to render something. Otherwise, we'll render this. So I'll copy this to both of them. So right now it's going to be down on both, but let's go ahead and put menu or chevron up when the menu is open and chevron down when it is closed. So there you can see it flips. Now there's a slightly better way to do this, and while we don't necessarily need this dependency, it's something that I use and it's pretty helpful. So we're going to add something called class names. So we'll say yarn add class names. This is just a utility, really just a utility function is all this represents. And if we use that, we can refactor this code right here. And in our class name, we can import class names. So we'll go to the top and say import class names from class names. And you can see this is just a utility, a simple JavaScript utility for conditionally joining class names together. Pretty common that you'll see this within React. So now what we can do is we can say we always know it's going to be FA solid. So that's similar across the two. And then depending on whether the menu is open, we will either use the chevron up or the chevron down. So we can delete all this. So now rather than conditionally rendering the entire element, we're just conditionally rendering the class names, which is similar to our original implementation. So this is a good one for me to pause on and kind of show you what React is doing for you versus what you'd have to do in a vanilla app. So if you remember, so this is just the menu, and if you remember in our vanilla refactor, or actually let's go to the live TS refactors, the latest one we did, and we go to JS and look at the view. And then let's go to the event listeners where we binded the click on the menu. So this first one is where we're binding the click event on the menu button. And that, let me just do this side by side so that you can see it better. So here's our React on the right, and then vanilla is going to be on the left. So vanilla React, and you can see that, let me zoom out just a little bit. Here's our actions button, and here is our click listener on that button. Then here's the state that controls whether it's open or closed. Now, that right there is the same as registering an event listener on the button over here in the view. And then we're calling the toggle menu class, which is down here somewhere. In the toggle menu class is going to select the items in the button and toggle some styles in a border, and then figure out which icon to throw on that. And that is being implemented right here, where we're deciding which icon to put, and then whether to show it as open or closed. Then furthermore, when we come down here to the menu being open or closed, here we're conditionally rendering the menu items based on whether it's open. And you can see we have to implement this whole toggle menu and entire close menu to do that, when it's pretty easy to just say like, hey, if that state is true, then render it, otherwise don't. So that's just kind of how we can simplify our lives a little bit. And then finally, we have the action handlers, where we register something that happens when the game resets or there's a new round. And you can see that we will register that on the game reset right here. So that's what we're doing with these on-click listeners. So just kind of a before and after look to see how we're translating things. So at this point, we can come back to our game and we can open and close the menu. And if we click one of these, we'll get something printed to the console telling us which one was clicked. Now we haven't actually handled those events yet, but we will do those shortly. At this point, our app.tsx is pretty much done. You could of course refactor this even a little more and add more components to clean this up, but this is pretty readable at this point, and I don't really want to try to go any further because there's no reason to. So now we need to add the concept of state to our application. And if you remember from the TS refactor, we had this entire store class, which was responsible for, at the very bottom, basically saving our state to local storage and then dispatching an event that said, hey, this state has actually changed, and then the app.ts was listening for that event here, and when it heard that event, it would re-render the view with the new state. Now, this whole process is totally native to React. It is, and if you think about it, what this is really doing is the view is reacting to a state change and re-rendering something. So the pattern that we've used here is a very simplified, oversimplified version of what React is doing and what the purpose of React is. We just had to do it in a much more indirect, imperative fashion rather than the declarative fashion that we're doing it in by just, saying like, hey, if this state exists, like if show modal is true, render the modal. We really don't need to do anything more complex than that. But because we're using React now, just because we're using React does not mean that our state is going to like change its shape or anything. We're still tracking the same fundamental types as defined here. So all we really need to do is redefine a useState hook that will keep track of that game state in the main app, and then we'll read that state in our JSX to conditionally render things and make things happen and make it interactive. Since all of the state works together and none of it's like isolated from one another, it makes sense that we would throw this in a single state variable. So we're going to call it state and then just use the convention for a useState hook. And we'll import that to React. And we of course need an initial state that we'll pass here. If you remember from the original, so let's go back to the store, the initial state that we passed was this right here. So what we can do is just copy this object and paste it into the default, or basically the function parameter is going to be the default state. Now, because we're passing this object shape to the useState hook, useState is going to use TypeScript generics to infer the type of state. And if you hover over state, it's going to give you that object shape. So we could explicitly define that right here and put it in the generic and define the type of state that we're dealing with, but it's just easier to let it infer that. And so now we have a strongly typed state object. Now this is where things get interesting. So we have this state object, and if you remember from store, we are just mutating this state or changing it in a couple of places. So when a player moves, we are pushing a move to the current game moves array. And when we reset the game, we are pushing current round games to the history. And then when we do a new round, we're pushing to the all games array. So those are really the only places that we're changing the state. And then the rest of it is going to be something called derived state. And that is basically where you are constructing you're constructing a set of information that you have derived from that raw state object. And two good examples of this would be our stats getter and our game getter. And in the previous refactor, that's why I called that derived stats and derived game, is because we're basically, in both of these, we're reading the current raw state, and then we are calculating things and returning that to our application so that it can use that information to do things. So same thing here. We're grabbing the raw state and then calculating all of this stuff. We're calculating if there's a game winner, the current player, and the status of everything. So this is all derived state. And we can actually, what you might be tempted to do is put, derived state and then set derived state in some useState call. But really, you don't need to do that. There's no point in doing that because now you have to keep these two state variables in sync with each other. If you read through the React documentation, it will kind of explain to you why that's a bad idea. All we really need to do, since this is a pure function, is come down here and define our game object, and then we need to make a method to derive that. So let's call it derive game, and then we also need to derive stats, not state, we need stats. So these are two empty functions that we've defined, And here we're going to derive the game, and then stats, we're going to derive the stats. Now, of course, we need to pass the state object into each of these. And it's going to yell at us because we haven't defined that as an argument. So all we need to do here is say state, and then we need to define the state shape. Now, this is where we need to start typing it. If we go back to our types.ts that we had defined at the very beginning, we have this game state key that we can use. So we can pass that here as game state and then import that as a type. We'll also put it right here. So state is game state. And now when we pass this state object into derive game and derive stats, it's going to accept it. And at this point, it's just a copy paste exercise. We'll go back to our store, which was, again, let me remind you, this is from our prior refactor. This is our vanilla application, not our React one. All we need to do is grab from stats. We can copy the return type of stats, and then in our derived stats, we'll just return that. And now we're no longer referencing this dot player. That is going to be, we need to define that. So we'll do that up here. So if we go back to store, I think we have a players array, or no, this was in our original app is where we put that. So here's our players config. So let's copy that to the top of our app.tsx file. So there's our players config. And then now we can just grab that from that scope, the global scope here, and map through it. And we have a derived stats object. So before we get any further, let's just console log this. So console log stats, because we've implemented that function. And if you go to the console here and refresh, you'll see that we have printed this here twice. And the reason that it gets printed twice is because we are in strict mode. So if you go back to entry point and see this wrapper right here, when we're in strict mode, React is going to re-render each component 2 times, and that is to catch bugs that happen. And I'm not going to go too far into that, but that's why we're getting both of these re-renders, not just one. But anyways, we get the player with stats and this derived object where it says player 1 has 0 wins and player 2 has 0 wins, and there are 0 ties. So just with that information, we can start to populate our React application. So if you go down here to the bottom, you can see that we have this static numbers down here denoting who has what number of wins. So what I'm going to do is grab the stats array, and we know from our config that player 1 is the 0 index and player 2 is the 1 index of that array. So all I'm going to do is interpolate a variable here, and we're going to grab the stats derived state, and we're going to look at the players with stats and grab the first player. And then we're going to print the number of wins in that slot right there. Then we can also throw the number of ties. So stats.ties, and then finally stats.players with stats. We'll grab the first index, which is player 2, and pass in wins right there. So at this point, our player 1 ties and player 2 are getting dynamically populated, and that part is done. So the last thing that we need to do is implement our derive game function right here. And we can do that by another copy paste. So store.ts from our original project, not the React one, we had this getter called game. And that was basically just calculating some things and returning some derived state. So let's paste that in there. We need to reference players from the global scope here. And there you have it. I think that should be pretty much it. We're referencing state right here, and that should work. So now if we print the game, so console log game, and refresh, here's the game. We've got the current player, which is player 1. There are no moves yet, and the status is complete is false. There's a couple things we can do now. Let's get rid of this console log, and let's also get rid of this show modal static variable. So get rid of that. we can grab that from the game derived state now. So instead of show modal, what we can say is, hey, is the game.status complete? And if the status is complete, then we are going to open up the modal, and instead of a static message, we will say game.status. I think we're going to need to do this dynamically. So if there is a winner, we're going to say game.status.winner.name wins. Otherwise, it's going to be a tie. So you can see how we're just reading directly from the state to get what we need, whether we need to render this and open it up, and what the message should be when it happens. But of course, this isn't going to matter if we're not rendering it within the game itself. So now what we can do is read the current state in the current game and figure out which squares need to be populated. So right here, remember, this is where we are looping through all 9 of our squares on the game board and rendering an icon if there's a move in that slot. So what we can do is grab an existing move. So let me show you where this originated from. So if we go to our original project and we go to the app.ts, I believe that's here, you can see that when a player moves, we are checking for an existing move. And if there's an existing move, we are returning because a player can't click that twice. And then we are calling player move. Furthermore, in the view, to figure out, which squares need to have icons, we have this initialize moves method. And what it's doing is it's saying for each square on the game board, see if there's an existing move. And if there is an existing move, then we're going to basically simulate a move and populate that square. So with React, all of this logic is way easier to do. So we can basically just copy that logic right here. And we're not looking at moves. We need to look at the current game, moves. And now the square ID is already a number. So we can just replace this entirely with square ID. So within this map function, we're figuring out if there's an existing move. And if there is an existing move, we are going to render that icon there. Now also remember, on each move, we have the player object available to us. So let's refactor this right here, the class name on this icon. Rather than a static X that is turquoise, we can use class names. So we'll wrap that. And let's just start over here. So it'll be FA solid no matter what. And then we're going to take the existing move, grab the player, and then give it the color class. And then we'll also take the existing move.player.icon class. And that will tell us what color and what icon to render right here if there is an existing move. So now if we go back to our game, the board's going to be empty. And we still can't click anything because we haven't listened for that event. So the last thing that we have to do to make this game interactive is add a click listener on this div or this square that we're listening for. So we will attach a callback function to this, and we'll say if there's an existing move, we're going to return early. So we're reusing this that we established up here. So if there's an existing move, don't do anything. Otherwise, we need to handle the player move. And this is going to require all the logic for handling a player move. So I'm going to separate this out into a handle player move function. And then I'm going to pass it the square ID of the clicked square. And then I'm going to grab the game.currentPlayer. And then we need to define this function now. So we'll come up here and we'll say function handle player move. It's going to take a square ID, which is a number. And then it will take the, what did we say? The current player. So player is a player. So now what happens is If there's an existing move, return early, otherwise handle the player move. And that's going to be defined in this function right here. So thinking back to our prior game, how did we handle a player move? Well, let's go to the view. This is our original game, not our React app anymore. And looking at the view, this is actually not what we should be looking at because this is all handled by React. We already implemented that. So we need to look at the store. So here's the player move handler. Basically what we're doing is we're getting a copy of state, we are pushing a move to the current game moves, and then we are saving that state. So let's go ahead and just copy that, paste it here, and instead of this.getState, we will just grab, actually let's comment this out for just a second. When a player moves, we know that we need to set the state. So let's call set state. And to get the prior state that we need to deal with, we can pass a callback. And this previous will represent the prior state from the prior render's snapshot. So we can access that here. So if we wanted to now place this logic in the set state callback and uncomment it, we can do a structured clone of the previous state right here. Then we can push something to the current game moves, and then instead of saving state, we will just return the state clone from this set state callback. And then the only thing we update here is we're grabbing this from the argument, so player goes directly here. And then what's it complaining about? This argument is not assignable to parameter of type never. And it's saying that current game moves is of type never array. And that's because we did not explicitly type this as a game move. So now we'll come through and actually type this out a little bit. And if we wanted to, what we could do is just cast this. We can say as game state. And game state is from our types.ts right here. So we can cast that to a game state object, and that's going to fix this because now it knows that the current game moves is a move array. You could either do that, or a better way to do it is just say use state is of type game state. And now that will explicitly say like, hey, the object I'm assigning here is of type game state. So now, if we handle the player move, we should start to see some interactivity here. So you can see that our app is starting to work and it detects a player win. Now, if we click play again, it's not going to do anything. And that's because we haven't set an event listener on the modal. So if we command click the modal to open that file, you can see that we're going to need an on-click handler. And that's going to happen when the user clicks play again. So on-click, and then we'll pass it that on-click handler, which is going to be in props. So this is really just a way of us to basically tell the outside world that's consuming this modal component, hey, there's an event and it's an on-click event. That means that the user wants to play again. So now we'll come down here and we'll say on click, and we need to do something to close the modal and update the state. So in this case, we need to reset the game. So reset game, but the problem is we don't have this implemented yet. So similar to how we implemented the handle player move, we will also say reset game. Oops. And now this is going to be a function that we'll call when that modal is clicked. So similar to how we are just calling set state and using the previous state to find our next state, we can do that here in reset game. So set state, we'll grab the previous state, and now we have to do something with that previous state and derive something and return the new state that we want the game to be in. Once again, we have already implemented this in our prior refactor. So let's go back to store.ts, which is where we implemented this. And you can see that we have a reset method, and then we have a new round method. We can pretty much combine these into the same method and just have like a Boolean check to see whether it's a reset or new round. So let's first copy over the reset. So we'll paste that in, and instead of get state, we're just going to pass the previous right here. And now what we're going to do is we're going to read from the game, which is our derived state, and we're going to destructure the status and the moves from there. And then finally, we'll return the state clone, which will set that new state for us. Now, like I said, in our original, we had a reset and a new round. So all we have to do is conditionally, let's just add a prop, or not a prop, but a parameter up here and say, is this a new round? And have that as a Boolean. So if we come down here to this reset game, we're going to say that's false. It is not a new round, it's just a game reset. And then if you remember from our menu, we have this on action. So what we can say here is we want to reset the game, and then to detect whether this is a new round or not, we'll just say, does the action equal new round? And if that evaluates to true, then we have reset the game. Otherwise, it'll evaluate to false, and that'll just be a plain old reset. So we've hooked up this listener. We just have to implement that, have to actually use this variable to figure out what to do. So all we need to do is come down here after we've reset the current game moves, and we'll say if this is a new round, so is new round, we also want to push to the history. So we'll say stateclone.history and then all games, and then we'll basically just push and spread the state clone .history.current round games. And then we will set that current round games equal to an empty array. So if there's a new round, we're also going to reset that. So at this point, we've got the reset game completed, and I think this is the majority of the logic. So let's go try our game out. So it detects a win, and if we click play again, it closes things, everything resets, and down here player 1 has 1 win. Let's get player 2 to win 1. So player 2 wins, we play again, player 2 has 1 win. Let's click a square, reset that, it seems to work. Let's go ahead and reset the scoreboard down here, and that seems to work as well. So I think we're pretty much done. Let me just kind of pause the video here and go through and see if there's any cleanup that we need to do, and then we'll be on our way. Okay, so there's actually one big thing that I forgot to come back to, and that is local storage. At the moment, we're not persisting this game across browser refreshes. So let me collapse some things. We'll collapse the players, derived game, and derived stats. We will collapse reset game and handle player move, just to hide them from our view. And you can see with our use state hook, this is where we're storing the state of the game. So if we were to play a couple moves and then refresh this browser, it's going to basically reset everything because we're not storing this to local storage any longer. And then furthermore, I realized that this turn indicator is not implemented. So let's go ahead and do that. We'll get rid of these data IDs because we don't need those anymore. And then this becomes pretty easy. So we just add class names around this. So FA solid, and then we will just figure out whose turn it is by saying the game.currentPlayer.color class, game.currentPlayer.icon class, save that. And so now this will be dynamic. And then finally, we need to just replace this right here with the game.currentPlayer.name. So this should make the color, the icon, and the name dynamic. Let's make sure that that's correct. Looks like everything's working except for that part because we have this as a static style. I think maybe an easier way to do this is just remove this class name altogether, remove that from there, and then use the entire div to specify the color. So we'll say game.currentPlayer.color class is going to apply to the entire div, which will style its child elements, and then we're toggling on the icon. So player 1, player 2, player 1, and seems to be working now. And once again, the last thing is local storage. And this is something that I'm not going to spend a ton of time on the implementation to, but there is a way that you can extract the local storage function to a React hook. So we can basically make a replica of useState, but instead of just using state, it will also keep it in sync with local storage. And in that manner, we can basically have the same interface while getting that additional functionality. So just so that we're not getting into crazy detail or anything, we already do that in these videos. I'm going to go into source and make a hook called useLocalStorage.ts. This is a React hook. You can learn more about this if you are in the React docs, and go to the beta docs, the new ones. And then you can go to, should be some hooks, a hooks reference somewhere. Let's go to the reference. So you've got the built-in React hooks. I don't know if it does say anything about like custom hooks and how you would do that. Oh, here, reusing logic with custom hooks. This is a good place to check out what I'm about to do and understand why we would do this. But I'm just going to copy paste everything in here to this file. This is a use local storage hook. And basically what we're doing is we are adopting the same interface as the use state, except we are also keeping it in sync with local storage. And you'll see right here, this is where we're like setting a value to local storage. This is where we are getting the value from local storage. And then in the parameters, we'll pass the key that we'll use to track that in local storage. So I've documented this a little bit. You can read through it on your own time. It's not necessarily super important to understand all the internals here. I'll also note that I've added this effect right here that basically keeps track of other tabs that change. So if you were, let me close some things out. And if you went back to our original implementation, app.ts, this is not the React app, this is the prior videos, you can see that we're listening for the state change. This has pretty much become irrelevant now that we're using React because that is kind of built into the paradigm of React. But we also have this where we're listening to the local storage of another tab and re-rendering the view if that changes. So I've created this effect here which does the same thing, and it will update this state variable every time another tab changes its state. So I will close this and you'll see how easy this is. We'll go back to our app.tsx and we'll just comment out this original state, and all we need to do, we can name it the same thing. So set state, state, and set state. And now instead of use state, we're going to use local storage and import that. Now it's going to ask us for a key. So we'll say game state key. And then it will ask us for our initial value, which is going to be this right here. The same thing that we passed earlier. So we'll uncomment that. So you're going to see how quick and easy this is to update. So remember, if we go to our React game, play some moves and refresh, not going to work. But all we have to do is replace use state with use local storage and import that from our file. And then we need to give it a game state key. That's just the key that will be used in local storage as that first argument. And then our default value is the second. And that should do it. That will keep the state in sync with local storage, and we don't even have to think about it. So we can play the game, refresh, and it will find the state that we're in after a refresh. You can also duplicate the tab, play something over here, and then that's going to sync up over on this side and vice versa. So now that we've got it synced up with a local storage, I think we have replicated that original application in full. So the last part of this is just going to be some cleanup and making things easier to kind of find and read through. So let's go through and look for any like data IDs. We don't need any of these because that was a paradigm from the original implementation where we needed a stable way to select a DOM element. So we'll get rid of all those. Let's go through our components, Should be okay there on the menu. No data IDs there, and we're good. And then furthermore, we can just extract some of these things out. So let's make a file called utils.ts. This will just be some utility functions. And if you remember, we have this derive game and derive stats, and then we also have the players up here outside of our component itself. So we can take all of this stuff. You could leave it here. There's no problem with that either. But I can throw all that into a utils file, and then we can export them from it. Okay, and then we just need to import a few types from the types file. So we'll import the player and then the game state, and that should satisfy these functions. So those are now isolated to the utils file, and then we of course need to import them. So command period to import from utils. Do that again here, and you can see we've got that import, and that should work. Okay, so that kind of cleans up our app file. We no longer need use state because we're doing the use local storage hook, which uses state under the hood. So we'll expand this out, and this is pretty much the final game. Once again, you can find all of this code in the repository I've left in the video description. Be sure to look at the TypeScript branch to find this exact implementation I just did. There's also a non-TypeScript version of this same app. So now that we're done, we can close out this developer server, the Webpack dev server. And a good thing to do is always to just check to make sure that it builds correctly. So we have these build scripts, and let's just run yarn build. And what this will do is basically check all your types, type checking, compile everything, bundle it up, and output it to the public directory with bundle.js. And we can also try the build prod to make sure that it does its optimizations okay and it doesn't complain about anything. So there you go. And then finally, we've got live server running on port 5500 already. And since we just built this app, it's totally static, and you can actually view this directly from the public directory rather than using the Webpack dev server. So you can think of it as Webpack came in, did its job, compiled everything, transpiled everything, and gave us one nice clean bundle output, and now we're just ready to go. We've got what we need, and the browser knows how to load the app. So let's go back to the browser, and we'll go to localhost 5500, close everything out. And I know we've got a lot of folders here, but let's go to the live React refactor, and then if we click public, it should give us the game, and we should be able to use it just like we were with the dev server. So we can reset, we can get a new round going, and just play the game. So just wanted to show you that's a good thing to do. Check your build, make sure it works, and then you could really you could deploy this game right here over any CDN because it's static assets. So you could put it on Cloudflare, whatever you want, and it can be served to your users, throw it on GitHub pages, what have you. So hopefully this was an educational video that hopefully you enjoyed seeing how we can go from a vanilla JavaScript application and port that over to React and kind of see the benefits of using React. It makes a lot of our code a lot simpler. We basically went from, let's just kind of recap, we went from this live TS refactor where we had an app. Let's just close all this out. You can just scroll through. This is our main app file where we're registering all the event listeners, controlling everything. This is our state where we have our store class. And this is our view where we are handling selecting all the elements up here. We are rendering here. So this is basically what React is doing for us. And then we're binding event listeners, got all of our helper methods here. And all of this stuff, it's pretty verbose what we've had to write here. We even had the delegate method so that we could figure out which square was clicked, and that was pretty confusing. So we've gone from this over to our React application which, as you can tell, if we go to app.tsx, it's pretty concise what we've got here. We don't have any delegate methods. We can just handle everything basically right here with some event handlers. We've got a hook that helps us deal with local storage. And then we have our components split out by their separate concerns, also with their separate CSS. So that's just a much cleaner way to write an application, and it's a lot easier to extend into the future. Let me know what you thought of this video. Be sure to give it a like and subscribe to the channel, and I will see you next time.